Let's learn about bar graphs and histograms. A bar graph is a graphical display comparing categories of data using bars of different heights. Bar graphs are used when the data is discrete. To indicate this, there's a space between each of the bars. So the word discrete here just means that it can only take certain values. So in our example, we have favorite sports. So we have basketball, football, soccer, baseball. Maybe there are other choices that weren't chosen, so maybe no one picked volleyball. Maybe nobody picked softball. Nobody picked running. But we can only have certain values. It's not like you could say, my favorite sport is football, basketball. Like a combination of the two, some mysterious new sport. That doesn't work like that. Or if you go to the store and you wanted to buy boxes of cereal, you could buy 1 box. You could buy 2 boxes. You could buy 3 boxes. You could buy 10 boxes. You can't buy 9.25 boxes. So discrete just means only certain values are possible. A histogram, on the other hand, looks similar, also using bars, but they're organized in intervals, and they represent continuous data. So the bars here, which are called bins, have no spaces between them. So anything dealing with time generally is going to be a histogram. So here we have the ages of presidents. Age is relating to time. So you could be between 40 and 44. You could be 40 years and 302 days. You could be 40 years and 303 days. Time keeps elapsing, so it's going to be continuous. Other things that might be continuous would be things like depth. If you're tracking how deep something is, how long something is, you could keep measuring to a smaller and smaller unit. So let's learn how to make bar graphs and or histograms and decide which one we need to use. So first, determine whether the data should be represented as a bar graph or a histogram. So can you only have certain values? That's your bar graph. Or is it going to be more of a continuous graph where if someone new joined, it could fall between? And that would make us use a histogram. After we've determined that, determine our appropriate categories or bins, and we're going to tally up how many would fall into each category. Next, we're going to draw bars for the height to show how many fall into each category or bin. And then, just like with dot plots, we're going to label our axes and title if we know what we're labeling. Example 3, determine an appropriate graph for discrete data. Our real context is the Olympics. The table shows the total number of Olympic medals won by U.S. athletes competing in selected events from the first Summer Olympics in 1896 through 2012. Make a graph of the data to show the total medals won in each sport. In this example, we're going to go through some steps to break down what the problem is asking and make sure we're answering it appropriately. So first, what's the task? What do we need to do? So describe the task in your own words. Then list any questions you may have, and maybe how can you find answers to your questions. Pause the video while you write down your thoughts. So for this task, we need to create a graphical display for the Olympic medals table. So our second part, how are we going to approach the task? What have we learned so far that we can use to help complete the task? Again, pause the video, write down your thoughts, your strategies for completing this problem. Hopefully you wrote something down about, putting numbers in order. We learned that already. Deciding if data is discrete or continuous. That was in our learn part. We learned the steps in our learned part. Next, we're going to figure out our solution. Here they gave us 5 broad events. Thankfully, they didn't include all of them because the Olympics has a bunch of different events. So for these 5, we're going to figure out the total medals in each event. So to figure out our total, we should probably add them up. So we're going to add the medals together. Pause the video, add the gold, silver, and bronze together to come up with the total. We'll check in just a minute. Let's see if your totals are correct. So boxing, adding them together, you should have got 111. Diving, 132. Swimming, 520. Track and field, 759. And wrestling, 129. Now, we are going to be making a bar graph since this is discrete data. There are not going to be answers that would fall between boxing and diving. They're not really related. So, let's make a bar for boxing that's 111 tall. If we look at our scales, on the side, we see it starts with 0, 800s up here, and then another little line above it. If we look, it's counting up. It took 2 lines to get to 200, so each line must represent 100. So every in between is our 100 between those 2 numbers. So now we just need to make a bar that's as tall as it says. So 111. Well, 100 to 200, we know it's going to be somewhere between those, but closer to 100. So boxing would be barely above 100, but not too much. Diving, 132, would be a little bit higher, not quite halfway between, that would be 150. Swimming, 520, would be up past that middle between 400 and 600, and then a little bit higher. 759 for track. Up between that middle line of 700 and 800, about halfway between. And then finally, wrestling is back down. So for this, we made a bar graph because we can't have data between our choices. And we might have been able to do a different scale on the side. They gave us counting by hundreds. It might have been better if we could have counted by 50s. We would have needed about twice as many lines. It would have been a little more accurate, but this is pretty reasonable for what they gave us. So last, how can we know our solution is reasonable? Write a brief argument that could be used to defend your solution and convince other people that you did it correctly. In this part, simply explaining how you went about it. So you added your gold, silver, and bronze together to get your total. And then explaining how you knew or how we knew how tall the bars were would be a good argument to defend your answer. Let's check to see if you understand creating bar graphs or histograms. Read through the situation and look at the table. Determine which graph, either a bar graph or a histogram, would best display the data. You're given a bunch of different countries and the number of players of video games they have in that country. Pause the video now and make a graph. Check your answer. If we're given this, so we can see our countries would be at the bottom and the number of players along the side. we would need to make a bar graph that would look sort of like this to show how many video game players there are. So the United States has the most, with Germany and Brazil being the second most, and United Kingdom maybe the fourth most. I'd be curious to see what China had, as they have the largest population in the world. Would it be significantly more than the United States, or would it be less? Also, South Korea has a lot of people that play video games. I wonder where they would fall on this. But we used a bar graph, again, because we can't have in-between countries. We can add a new country, but that's not merging with a country that's already there. Example 4. Determine an appropriate graph for continuous data. Our real-world context is a marathon. So the results of the top finishers of the 2015 New York City Marathon wheelchair division are given below. Determine whether the data are discrete or continuous, then make a graph. We are given a bunch of times. So first we're determining discrete or continuous. Because the racers can finish with any time, not just the ones that are listed, if there was a really close race, right, one racer leans right at the end, we might have 1:30:54.2 compared to 1 hour 30 minutes 54 seconds 0.3. This data is continuous. Time continues on no matter where things fall. So for time-related things, we're going to use a histogram. There are other instances. Time is the most common for a histogram. Next, our data was spread out over several minutes. If we look, they were nice enough to put it in order for us, but it starts at 1 hour and 30 minutes, ends at 1 hour 43, and there are seconds labeled after. This one has 54 seconds, this one has 5 seconds, this one has 37 seconds. I don't want to make a graph that has 60 seconds for 13 straight minutes. That's going to take a lot of little sections. So we can take what we did with dot plots and scale our axis. So we're going to group the things together by the minute. So anything that fell within that minute, we'll just put together. So there were 2 times in the 1:30s. Then our next one, there was 1 time in the 1:34s, 4 times in the 1:35s, 2 times that had 1 hour and 36, 1 for 1 hour and 38, 3 in the hour 39s, 1 in the hour 40s, and then our last place of this group was 1 hour and 43. If you notice, there are a bunch of places that fell in with 0. We still need to make note that those are zeros. That will just mean that those buckets will not have any data points to it. The bar will be at 0. So when we graph it, here they did step 3 for us. So we're going to draw the bar graph to represent each bin. Label the axis, include a title for the graph. So we can see there are 2 racers in 1:30s, 1 in the 1:34, just like we had tallied up. For our labels, pause the video, think about it for a second. What should we label our axes? What would be a good title for our graph? Our x-axis on the bottom is our time, and the values are hours, followed by minutes, followed by seconds. And our y-axis, going up and down, the bar height tells us how many racers fell into that bin. As for our title, These are our marathon results for the wheelchair division, but we can just say marathon results. Now check to see if you understand making histograms. Read through the context using the table, pause the video now, and create a graph that best displays the data. Check your answer. 18 to 24 had 45%. 25 to 34 had 26%. 35 to 44 had 13%. Then we had 10% and 6%. Finally, our last group, 65 and older, was just 1%. Again, notice with our histograms here, because age, continuous thing, if you're 24.5 or 24.75 years old, still got to fall somewhere. The bars are connected together with no space between them.